Alrighty, hello and welcome to the wolfSSL live webinar, getting started with MQTT presented by wolfSSL engineers Eric Blankenhorn and David Garski. My name is Kajal Sapkota and I will be moderating this webinar. All attendees will be in listen-only mode. If you have any questions, please feel free to use the Q&A box or raise your hand to be unmuted if you would like to ask the question live, as we will host a Q&A session following the presentation. The webinar will also be recorded and made available on our YouTube channel shortly after the presentation. I invite you to follow us on Twitter at wolfSSL as well as our other socials. And please feel free to email us at facts@wolfSSL.com if you have any additional questions. And now I'd like to give a brief company overview before we move on to the technical presentation. wolfSSL was founded in 2004 by Todd Auska and Larry Stefanik when they realized there wasn't an open source dual license embedded SSL library available. OpenSSL existed at the time, but there was a demand for an alternative that was easily portable, smaller, faster, available under a clear commercial license, was equipped with a clean and modern API, and offered commercial-style developer support. wolfSSL was born into this market need with an OpenSSL compatibility layer. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL is made up of almost 40 dedicated employees in 2020, most of which are engineers. This process, of course, is supported by a strong partner network that we're proud of, which includes NXP, Intel, DDSI, for example. Since the beginning, our engineering team has developed several embedded security products, including wolfCrypt with DO178 support, FIPS certification, and a FIPS ready offering, MQTT up to the version 5 specification, SSH version 2, TPM 2.0, a secure bootloader known as wolfboot, as well as Java wrappers and JSSC support, and commercial support for curl. All these offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. And now I'd like to turn it over to Eric and David to talk about MQTT.
Excellent. Thank you, Kajal. So hello, everyone. Thanks for attending our webinar. I am Eric Blankenhorn. I'm an engineer here at wolfSSL, and I'll be discussing the basics of the MQTT protocol and how the wolfMQTT client can help secure your IoT network. We'll start with a discussion about the specific needs of the Internet of Things, which will lead us to an overview of the MQTT protocol itself. Next, we'll review the different specifications that are supported by the wolfMQTT client library. Then we'll take a look at the architecture of the library, including a quick look at the configuration options and the build process. That leads us to talk about the many rich client examples available alongside the core library. Next, we can look at some of the ideas we have for the roadmap of MQTT. And lastly, we'll answer any questions that you might have about the protocol or wolfMQTT specifically. The primary concern of many IoT projects is one of resource constraints. These devices may have tight power budgets or small memory availability, or they might be operating on networks that are either unreliable or expensive, each of which requires minimizing the amount of data transferred. The MQTT specification is free to use, which has greatly enhanced its popularity among developers of devices that number in the tens of billions. Since the protocol is easily scalable, industries across the spectrum have found it to be suitable to their application. Also key for developers is how friendly the API is. There are really only 8 primary functions in the wolfMQTT library needed to have a fully functioning client. So MQTT stands for Message Queuing Telemetry Transport, or MQ Telemetry Transport, depending on who you ask. It was designed specially for lightweight embedded type systems, but scalable to allow for efficient large networks. Individual MQTT packets are very small, and publishing a short message, including overhead, is in the tens of bytes. The publish and subscribe methodology allows publishers to send lots of small bits of data that are related to a topic. Then that data will be sent to the subscribers of that topic. This allows a loosely coupled system in which devices do not need to have state knowledge of their peers to communicate with them. Through the use of repeaters and bridge devices, the peers don't even need to exist on the same network topology. Even more important to devices that may be powered off to conserve resources, messages can be stored and resent until the transmission is successful. So brokers are the central point of contact for all of the MQTT clients. Brokers act as the directory of all connected clients, the index of all the topics, and the distributor of all the messages. So choose your broker wisely. The protocol specifically recommends using TLS to secure MQTT traffic. Devices that need to go offline to conserve power can use session resumption to quickly reestablish the connection. This level of protection adds overhead, of course, but luckily we have the world's best TLS library available, wolfSSL. Quality of service is useful for defining a message's integrity. So things like network capability, tolerance for missing data, and tolerance for duplicate data are all considerations when choosing the quality of service level. When a client subscribes to a topic, a QoS level is specified. Likewise, when a client publishes to a topic, a QoS level is specified. The QoS level is determined by the party with the lowest quality of service. In other words, client A can publish at QoS 1, but if the subscriber client B used QoS 0 to connect, then the client B will only be sent a QoS 0 version of their message from the broker. So let's talk about QoS 0. With QoS 0, the broker does not acknowledge the receipt of the message, and the message is not stored or retransmitted by the sender. So QoS 0 is really best suited for a stable network or for non-critical data. Imagine something like a rain gauge sensor that reports data every minute. So a couple of minutes of readings lost here and there is probably okay. With QoS 1, the sender stores the message until it gets a PubAC acknowledgement packet from the receiver. In this case, a message could be sent or delivered multiple times. This is suitable when data is critical. In other words, it must be delivered, but it's okay if duplicate data is received. Also, network restrictions like bandwidth or cost don't allow for the full QoS 2 handshake, so this is why you might want to go with QoS 1. Imagine something like a blood pressure monitoring application that has sent reports from a sensor containing a timestamp and the blood pressure reading of an astronaut. So super high cost for the network and critical data. The application can ignore readings with the same timestamp, so you can have duplicates, but all of the readings do have to be recorded. This would be a good candidate for QoS 1. So quality service 2 is the most thorough, but also the most costly. It takes 4 transactions for each published message to complete a delivery. QoS 2 should be used when the application cannot handle multiple messages, so no duplicate data can be received. For example, like a firmware delivery that would waste precious network bandwidth receiving a duplicate message, or perhaps require all of the device's storage capacity to even receive the payload. You wouldn't be able to do it, so that's why you'd have to go with a QoS 2. That brings us to the protocol overview. So the MQTT specification allows up to 256 megabytes of payload per message. However, the actual payload maximum is often limited by the broker. For example, the limit for Amazon Web Services, or AWS, is 128 kilobytes, while Azure limits client-to-broker transfers to 256 kilobytes, and broker-to-client messages are limited to only 64 kilobytes. Again, choose your broker wisely. The last will and testament allows other clients to be informed when devices have lost their connection to the broker. During a normal session, a client would disconnect, indicating an intentional orderly shutdown. But if a broker loses the connection ungracefully, then the disconnected client can inform its peers using the last will and testament message. Also, as you can see, there are only 14 packet types for the 3.11 protocol. So it makes it very lightweight and easy to implement. Packet sniffers like Wireshark are aware of MQTT traffic by the packet header. It can be very useful for a client application to send a single subscribe packet or on initialization and be notified of messages from multiple topics. The term publish here refers only to the message type. A message that is published by a client will be sent to the broker. The broker will then publish that message to all the clients who are subscribed to the message's topic. Messages can also be marked for retention to be stored on the broker. If the message is retained by the broker, then new clients will be sent that message when they first subscribe. This can be useful for conveying information like system state. So, wolfMQTT has support for version 3.11. It's a successor to version 3.0. It's the only protocol version currently supported by AWS and Azure. Most implementations of MQTT today are using 3.11 standard. Version 5 was completed in March of 2019. It adds support for properties to be sent along with the command packets. Properties are a simple way to add custom metadata to the in form of the key pair values, in the form of key pair values. These can be used, for instance, to describe the format of the payload data. Recovery from command failures can be complex, and new error messages from the broker can be used to help the client know what went wrong during a failed subscription or publish. Topic aliases, they allow for integer representations of complex topic names. This can significantly reduce the bandwidth required for messages. The sensor network protocol was developed around 2009 to enable battery-powered devices on low bandwidth wireless networks to benefit from MQTT. The SN protocol allows a gateway device to communicate the full MQTT messages to a broker over a normal TCP-capable network. The message packets from an MQTT SN client to the gateway are even smaller than MQTT through the use of topic IDs, a 2-byte value that is used to represent a topic name. MQTT SN typically operates over UDP instead of TCP. So now we'd like to ask you guys for a little bit of information. So could we do a quick poll? Could you all please take a second and tell us what MQTT protocol your application is currently using? If you don't currently use MQTT with your application, then which protocol do you think it would fit? We'll give you about 20 seconds here to respond. Hopefully those responses are all piling in. Excellent, thanks. Thanks for your responses. So now we'd like to take a, sorry. The MQTT library is organized into three distinct components: the client, the packet, and the socket. The client contains the actual API functions listed here. You got connect, disconnect, publish, subscribe, unsubscribe, ping, and wait message. The packet component is where you can find all of the internal functions for building and parsing the packet structure. And lastly, the socket component is the interface for the lower level networking layer. This could be straight through to TCP, or it can be enabled to use TLS, courtesy of wolfSSL. As you can see, it's pretty easy to configure the library for the various protocols and features that are supported. If you disable the TLS support, then the wolfMQTT library can actually be compiled and run completely independent of wolfSSL. But why would you want to give up that world-class TLS connection? Debug messages are crucial for figuring out why your application is not quite working right. So you got the enable debug right there. The last one there, multi-thread, that allows for independent tasks to use the library without any internal conflicts. This adds some overhead, so we made it configurable so as not to bloat the whole library for size-conscious applications. So building the library is very straightforward. You'll have to watch another webinar for the instructions if you want to install wolfSSL. Just kidding, it's in the README. After cloning from GitHub, you simply do an autogen, configure, and make. That's it. As you can see, we calculated about 16K for the full library, so great for low resource implementations. Great, now let's talk about the examples. Examples are a crucial but often overlooked part of any successful library. We've taken the time to share as much as possible. The standard MQTT example is quite powerful. You can specify a host, port, quality of service, topic name, etc. Pretty much everything you need to test a broker connection. It's also where the MQTT version 5 specific parts live. The non-blocking client is very popular with the microcontroller crowd. The multi-thread example uses a publish task, a subscribe task, and a wait message task, and a ping task to demonstrate that feature of the library. The firmware example is pretty nifty. It has two parts. The first, FW push, uses wolfSSL to build a hashed and signed firmware image and publish it to the broker. The second part, the FW client, is subscribed to that same topic and is waiting for the firmware to be published. When it receives the firmware message, the image is unpacked and verified. So basically all those steps you would use if you're going to update some client device. Whereas the other examples use a couple of shared utility files, the MQTT simple demo is completely self-contained. It's very straightforward. The sensor network client requires another component besides the broker called a gateway. The gateway handles communication over UDP on the sensor network side, and it retransmits the messages to and from a broker on the TCP side. And we've got instructions for getting all those components and setting them all up in the README. So now the big three. Based on support questions, these brokers probably account for about 75% of the wolfMQTT client library usage. That is to say that roughly 3 out of 4 users of wolfMQTT are connecting to one of these brokers. So those are our examples. They are all neatly contained in the examples folder. There you can also find a couple of utility files that contain code that is used by the examples, but not necessarily needed in the wolfMQTT library proper. The simple client executable is roughly 9K, so perfect for your low resource applications. There in the output window, you see the MQTT client executing. You can see that the client's connecting to the mqtt.eclipse.org public broker. This is what we've got set up as the default. You can see that the TLS is being used to secure the connection. You can see the connect, the subscribe, the publish, and there it is. Yes, that confirms it. This webinar is awesome. So it brings us to our last poll question. We'd like to know what your application is using for the broker side of the connection. We'll give you just a few moments to pick one. Remember, choose your broker wisely. So up here we've got AWS, Azure, IBM, Watson, IoT, Mosquito, something else, and I have no idea. So just let us know what you're using or what you might like to use. I'll give you just a couple more seconds on that. Excellent. Thanks for your participation. So that brings us to where we're going. So this list consists of things that some folks have asked if we have, and some things that we just think would be really neat to have. We currently support TCP and TLS, but WebSocket support is always gaining momentum. We can always use more examples. One that we have planned right now is a Google Cloud Platform demo. GCP uses JSON web tokens for authentication, which is really simple with wolfSSL. A full command line interface that would allow scripting applications could be really neat. Currently we have the MQTT SN library and it's not secured. The nature of sensor networks often means it's not feasible to add overhead or use more power, but we're the kind of people that think all data should be encrypted. So we could use something like DTLS from wolfSSL to encrypt all those packets. And we're always interested to hear what else we should support. So please keep the suggestions coming. And that brings us to the end of the slides. So I'd like to open the floor to questions now. Kajal, do you have any questions for us yet?
No questions so far. How about we give them a few minutes, and while we're waiting, I can share the poll results.
Great.
So these are going to be the results of the first poll, which is which protocol is your application using? And if you take a look, I guess most people are using MQTT version 3.1.1, or they have no idea, which in parentheses is probably that version. Do you like to talk more about it?
Yeah, that's kind of what we expected there. So 3.11 is the de facto standard, like we said. It's also what's in all of the major brokers. So I imagine that we'll start seeing version 5 support creep up as applications start needing support for those extra features. It's interesting that there's MQTT-SN clients up there. It's something we occasionally get questions about, and I think it's got a lot of growth potential. So good to see those.
Okay, we have a question here. Oh no, you stopped raising your hand. Can you raise your hand again? While we're waiting for that, we've got a few questions in our Q&A box. The first one is, what is the difference between last will and disconnect callback?
Oh yeah, sure. So the last will is actually a separate message that's going to So basically when your client connects to the broker, you're going to specify that last will and testament message. So that could be something as simple as, I'm not here anymore, so turn off all the resources that may have been using me. And basically whenever the broker notices that the client is disconnected ungracefully, that last will and testament message will get sent out. The disconnect callback is for handling things like reconnection or maybe cleanup on the application end.
What is your recommendation for deploying a broker in a private cloud? Would you just write your own?
Yeah, so there are a lot of good open source implementations for brokers. Mosquito's probably the most prevalent. There's also HiveMQ has a implementation out that's under I think it's Apache license that you can use. You could certainly write your own depending on what kind of features you need available. There are some complications with the broker end, so storing those messages while clients come online and haven't subscribed yet. So there's a lot of things to think about as to how feature rich you want it to be if you would attempt to write your own.
We are currently using the wolfSSL for TLS 1.2. Can I just replace it with wolfMQTT for to just add support for MQTT?
So it's not really a replacement so much as it is an addition. So MQTT sits higher up on the stack. So it's an actual application that's going to run, and the packets that would normally be sent out, unsecured MQTT packets, those are going to go through the TLS layer and get encrypted before they're sent out. So they actually work together. Since wolfMQTT and wolfSSL play so nicely together, it's super convenient. You just turn on an enable flag and you're using secured traffic.
Why was Google Cloud not included in your list of data brokers in your survey?
Good question. So we have had some interest in Google Cloud, and it's definitely one of the top ones. Should have put it on the list probably. So it's moving up from others. Next time it'll be on there.
And if you would like to take a look at the poll, I'm sharing the results for the second poll right now. Oh, and this is a lovely comment from an attendee. Not a question, but excited to see examples with use on Google Cloud Platform. Thanks for the included examples so far.
Fantastic. We're going to get that out soon, promise.
What is the RAM usage for wolfMQTT plus wolfSSL on a embedded platform like ARM Cortex M0 to M4?
Sure. So these footprint questions are always tricky to answer because there's so many variables involved. Usually if you're going to be on an embedded platform, you're already going to be kind of optimizing the TLS library for maybe only one or two ciphers. So I think that's something we'd have to, you could contact us and we could go into more depth about your particular application.
How do you mitigate the performance issues with wrapping data with TLS?
Sure. So wolfSSL is highly optimizable. That's how we get around it. So that's basically by using wolfSSL in an optimized form, you can I forget what the actual numbers are for performance, but that's our methodology.
And I'm just getting started with wolfMQTT. Do you have some information links to help with understanding this topic?
Absolutely. Please send us an email or go to support, and we'll post some more links up there. You can start by just going to wolfSSL.com and look for the MQTT page.
Yeah, we have a lot of great resources on our website. If you go on there and then look at the MQTT page, we have links to reports and documentation and everything on there. It seems like most embedded Wi-Fi silicon vendors, example, Sidelabs, TI, Microchip, or Dialog, have their own TLS and MQTT client implementations that are provided for free within their SDKs. What are the advantages to using wolfSSL over these?
Well, I mean, the obvious ones are going to be licensing, also size. They've always done some optimization on their side, but imagine if you want to upgrade that and then those optimizations don't work anymore. So portability is another key answer there. Probably those are, I'm not sure what those are going to be written in. Ours is a straight C implementation, so that's another advantage for some people.
And how can implementation be so small? Or how can
so really, it's a very small protocol. So there's not a whole lot there. That number I came up with was using the MQTT simple application. So the application isn't doing a whole lot, but it would be something that maybe your common sensor would do. So it's just going to go into a loop and send a message and then wait for it subscribes to a topic and then waits for another message. So there's not a whole lot going on there. That's why it's so small. But again, the library itself is only 16K. So yeah, it's a great for these low resource devices and applications.
Alrighty. We've got a few more questions. I've been using AMQP RabbitMQ for my project. How do I determine if I should switch to MQTT? Is this just a matter of preference?
So I think it is a matter of preference until you get to the point where maybe you're having to do protocol translations for other devices that you want to bring in and be interoperable with. So at that point, I think it's a good idea to go ahead and choose one protocol. Yeah.
And then someone had a question on copying the Q&A questions. I don't think there's a way to copy the Q&A questions, but if you guys would like, after the presentation, I can send you a link to all of the Q&A sessions that were answered at this time. And then, does anyone have a MQTT SN Edge device or hub available? Are there any you recommend?
So the MQTT SN uses gateways, which I guess is what you're referring to here. There's two types of gateways. There's basically a gateway that's just going to straight broadcast the messages into another SN network. And then there's also a gateway that's going to translate those MQTT SN packets into MQTT proper and send those on to a broker. So there's a couple implementations for gateways. We do link one in our README. It's an open source PAHO implementation. So yeah, I think that's a good place to start, and then go from there.
What is the difference between MQTT unencrypted on port 1883 and MQTT SN?
So TLS, MQTT is using TLS, and MQTT SN is usually going to be on UDP, or it could be like some other Bluetooth stack network or Zigbee or something else. So that's the reason you would want to use the MQTT SN over the standard MQTT 3.11. And the SN network also has support for like we said, the topic aliases. So you can actually have like a published packet that's only like 4 bytes long or something. So when you've got very restricted bandwidth or network requirements, that's when you're going to see a performance improved, or just you'll have to use that sensor network protocol.
And those are all of the questions so far. Thank you everyone for attending this webinar. As a reminder, I would love to invite everyone to follow us on Twitter at wolfSSL, as well as all of our other socials. And if you have additional questions you'd like to ask about MQTT or any of our other products or topics, you can email us at facts@wolfSSL.com. And this webinar will also be recorded and made available on our YouTube channel, which we will also send out in a email after the fact. Thank you so much for attending, and thank you, Eric and David, for this wonderful presentation.
Excellent. Thanks for all the great questions, guys. And we'll look forward to hearing from you soon.